بریم به ادامه فیلمامون.
The single degree of freedom system is a basic approach to explaining how vibration occurs in machinery. On this grinder, we can measure vibration caused by unbalance. If we take a closer look, we can see that the unbalance is caused by a heavy spot on the rotor. As the rotor rotates, the heavy spot wants to fly off the rotor due to centrifugal force, X. The rotor stiffness, K, resists this force. The interaction between these two causes vibration, which can have a negative effect on machine components.
البته این رابطه که اینجا نوشته غلطه.
With the falcon and W effect on machine components.
این باید MX دبل دات باشه، یعنی دو بار مشتق نسبت به زمان گرفته شده باشه که این اصلا این معادلش اشتباه هست. خب حالا بریم جلو.
Components. With the falcon and WLS sensor, we can measure the vibration to get a diagnosis of unbalance and its severity. Using the balancing kit that corresponds with the
توصیف میکنه برای سیستم های دوار. برای پمپ های سانتریفیوژ. خب بعدی رو ببینیم. این توصیفی برای تعمیرات پیشگیرانه predictive maintenance. ببین چقدر صداها شما هم فرق داره. خب بریم جلو.
We are starting with both bearings off. The bad bearing is recognized. See the red line. The good bearing is recognized. See the green line. The bad bearing. The good bearing. Now let's create some interference. The classifier is not confused by this kind of interference.
خب خیلی از این فیلم متاسفانه نشد نکاتش رو بیرون بکشم و براتون بگم. خب بریم بعدی رو ببینیم.
Ultrasound is a very effective technique.
بیرینگ ها هست یا تاقان ها. ببینیم این رو.
Ultrasound is a very effective technology for bearing condition monitoring and predictive maintenance. You can get an early warning of failure in all bearing speeds, high, medium, or low. Establish contact between the bearing and the instrument and listen. You should hear a smooth, rushing sound. If you hear any other noises, that might indicate a problem with the bearing. Create a route in the DMS software with the baseline decibel values. Load that route onto the instrument and start your inspection. Compare your reading to the baseline to verify the condition of the bearing. For more advanced diagnostic, make a sound recording and analyze the sound spectrum using the spectralizer software.
در واقع یکی از جدیدترین دستاوردهای حوزه آلتراسونیکه برای تست بیرینگ ها. حالا ما اینو بیاریم اینجا، اینو ببینیم.
ऑयल एनालिसिस किसी मशीन के लिए कैसे आप ओनली ऑयल के माध्यम से ही पूरी मशीन की हेल्थ का पता लगा सकते हैं। ये उसी तरह है जैसे मान लो आपका जो आप
این خیلی جالبه، آنالیز روغن در کشتی. خب این خیلی مناسب این بخشمون نیست، چون میخوایم یک نمای در واقع شهودی از مسئله
हेलो दोस्तों, नमस्कार। विजिलेट में स्वागत है। मैं बीसी पटेल। आज एक अलग सी टेक्निक
مدیرافی رو میخواد توضیح بده. بذارید ببینیم. بله
The infrastructure that supports our modern
So, hello, good morning, good evening. No, maybe not evening, but good afternoon.
دیگه چون 57 دقیقه فرصتش نیست، ولی بهتون توصیه میکنم که خودتون
The infrastructure that supports our modern way of life is vulnerable to movements in the
این فیلم رو خودتون در یوتیوب ببینید. ولی چون میخوام توضیح بدم مجبورم که
until failure occurs. Repairs can be costly and time-consuming.
خب اینم میذاریم عهده خودتون این فیلم رو ببینید، چون بیشتر تئوریکال توضیح میدن. ما میخوایم به صورت اکسپریمنتال ببینیم چه اتفاقاتی میفته. خب اینو ببینیم.
Wind turbines do not warn you in advance. ACM Wind is an innovative low-cost monitoring system that detects failures in the rotating machinery of the wind turbine. A microphone through the ACM Wind system listens and memorizes noise patterns generated by the machinery. The system recognizes failures in an early stage before something occurs. ACM Wind does not affect the manufacturer's warranty.
خب خیلی توضیحاتش مناسب نیست. خب اینو ببینیم. بیاریم monitoring and lubrication machine testing with sonophone.
Machine testing. If machines and systems do not run smoothly, this can result in expensive failures and production downtimes. In order to prevent this, Sonotech has developed the Sonophone. The digital ultrasonic testing device helps to assess the status of machines and systems safely and reliably. Here's how it works. Ultrasound is generated as a result of friction between mechanical components, such as bearings. The high-frequency signals contain valuable information on the status of the machine. These signals are not perceptible to humans, but can be made visible and audible thanks to the sonophone, making it possible to detect damage in good time and to introduce preventive measures. Structure-borne sound sensors are used for machine testing with ultrasound. The interchangeable attachments with modular design allow for excellent versatility of components, such as the broadband sensor BS20. Simply connect the innovative sensor to the device, start the app, and start testing. Recording can be started and stopped directly at the sensor, and a quick glance at the touchscreen will show how powerful the sensor is. The spectrogram shows all signals within the frequency range of 20 to 100 kHz, and these signals can be used to draw conclusions regarding the status of the machine. The tester then adds photos, comments, and voice menus relating to the test point before moving on to the next one. Once testing is complete, the service engineer can create a report with just a few clicks. Alternatively, the data can be evaluated on the computer using the PC software. The Data Viewer software allows the user to play back all recorded testing data. Relevant areas can be investigated in more detail, and the data can be exported for further processing. Is the bearing still intact, for example? Do measures such as lubrication or bearing replacement need to be implemented? The service engineer can answer these questions using the audible and visual feedback from the sonophone, the ultrasonic testing device for the maintenance of the future.
The ground beneath our feet. We've developed a novel approach for monitoring performance and safety of infrastructure by listening to soil as it deforms. Acoustic emission are high-frequency noise that are generated by soil grains as they deform against each other, and when they interact with pipelines, piled foundations, or by seepage and erosion in earth dams. And by listening to acoustic emission, we can detect problems and provide early warning of failure. Our know-how has been used by RST Instruments to develop the world's first commercially available acoustic emission sensors for geotechnical applications, and they've called the sensors geoacoustic aware.
Acoustic emission monitoring has many benefits over existing techniques. It's lower cost, it's easy to install and use, and sensors can be retrofitted to detect deterioration of existing infrastructure. The system can be used to monitor long lengths of buried infrastructure. For example, a series of sensors can be attached to a pipe, and the acoustic emission monitoring used to detect areas of deformation which can provide information on failure. Our acoustic emission monitoring expertise has been used to design an award-winning landslide early warning system. Community Slope Safe helps to protect vulnerable people living on slopes. Continuous monitoring of these slopes can provide a real-time early warning of landslides. Trials totaling 130 years of slope monitoring in several countries has proven that the system works. To find out how our expertise can help solve your infrastructure problems, please get in touch.
چون همه چیز به صورت مصوره من حقیقتا نیازی به توضیح نمیبینم چون کاملا گویا هست. ببین این رو
65 days a year, avoiding expensive breakdowns, improving the reliability of installations. Industry is constantly dealing with these issues. To keep plants operational at all times, many industries have established predictive maintenance programs. One of the most valuable diagnostic tools for any predictive maintenance program is thermal imaging. FLIR Systems cameras contain all the features needed for quick and powerful thermal inspections. Electrical cabinets and motor control centers are regularly scanned with a thermal imaging camera. If left unchecked, heat can rise to a point that connections melt and break down. As a result, fires may break out. Besides loose connections, electrical systems suffer from load imbalances, corrosion, and increases in impedance to current. Thermal inspections can quickly locate hotspots, determine the severity of the problem, and help establish the time frame in which the equipment should be repaired. One of the many advantages of thermal imaging is the ability to perform inspections while electrical systems are under load. Since thermal imaging is a non-contact diagnostic method, a thermographer can quickly scan a particular piece of equipment from a safe distance, leave the hazardous area, return to his office, and analyze the data without ever putting himself in harm's way. FLIR Systems thermal imaging cameras are perfectly suited for electrical inspections. They're highly portable, ergonomically designed cameras ready to be used several hours per day. FLIR cameras deliver crisp, high-resolution thermal images that will register temperature differences as small as 0.03 degrees Celsius. They contain all the necessary features to make well-informed decisions. Useful features include a touch screen, scalable picture-in-picture, which makes it easy to locate areas of interest. thermal fusion, which merges visual and thermal images to offer better analysis.
این بیشتر در واقع داره توضیح برای سیستم‌های الکتریکی میده. ولی خب برای سیستم‌های مکانیکی هم مباحث ترموگرافی خیلی کاربرد دارن. ما تو ایران تو مباحث سیستم‌های الکتریکی هم از ترموگرافی و حالا اون اپروچ هایی که توش استفاده میشه خیلی استفاده میکنن و صنایع مختلفی من دیدم که از این تکنولوژی استفاده میکنن. خب بقیه‌اش ببینید.
Notes. The ability to save both a thermal and visual image allows showing the location of the hotspot to the people who will be making the repairs. Also, distribution transformers benefit from the use of thermal imaging. Examples of failures in low and middle voltage equipment are high resistance connections, corroded connections, internal fuse damage, internal circuit breaker faults, and poor connections and internal damage. Thermal imaging cameras are also commonly used for electrical high voltage inspections. As electrical connections become loose, there's a resistance to current that can cause an increase in temperature. This can then cause components to fail, resulting in unplanned outages and injuries. In addition, the efficiency of an electrical grid becomes low prior to failure. Thus, energy is spent generating heat, causing unnecessary losses. Power transformers are often checked with thermal imaging cameras. Temperatures of the cooling fins and the high voltage connections can be compared so that if necessary, corrective action can be taken before real problems occur. Also, high voltage power lines can be inspected with a thermal imaging camera. Other high voltage installations that are checked with a thermal imaging camera include circuit breakers and switches. Potential problem areas will clearly be shown on the thermal image. Examples of failures in high voltage installations are oxidation of high voltage switches, overheated connections, incorrectly secured connections, insulator defects. In many industries, mechanical systems serve as the backbone of operations. Thermal data can be an invaluable source of complementary information to vibration studies in mechanical equipment monitoring. Mechanical systems will heat up if there's a misalignment at some point in the system. Thanks to features such as line profiles, you will immediately see if there's a problem. Conveyor belts are another example of moving parts. If a roller is worn out, it will clearly show in the thermal image so that it can be replaced. Typically, when mechanical components become worn and less efficient, the heat emitted will increase. Consequently, the temperature of faulty equipment or systems will increase rapidly before failure. Motors are also widely inspected with thermal imaging cameras. Motors can be observed for brush contact wear and armature shorts, both of which typically produce excess heat, but not necessarily vibration, prior to failure. Thermal imaging gives a full overview and allows to compare the temperature of different motors. When necessary, further examination of the overheating motor can be done. Most FLIR cameras are equipped with a laser pointer which eliminates the tendency to finger point in dangerous areas. Examples of faults that can be detected with thermal imaging are overheated motors, suspect rollers, overloaded pumps, overheated motor axles, hot bearings. Thermal imaging also gives valuable information about the condition of pipe, tube and valve insulation. A thermal imaging camera can quickly give an overview of the entire installation. There's no need to check each pipe individually. Thanks to analysis tools like spot meters, line profiles, areas, isotherms, and many more, potential problem areas will be clearly identified, and the repairs can be done before real and sometimes dangerous problems occur.
ببینید اینجا برای سیستم های گرمایشی، سرمایشی یا برای لوله ها و پایپینگ ها دقیقاً داره نشون میده که کجاها اطلاق حرارتی.
FLIR thermal imaging cameras are also used to inspect ovens and drying installations. Thermal imaging cameras are also used in the petrochemical sector. They provide rapid, accurate diagnosis for furnace maintenance, refractory loss management, and condenser fin diagnosis. Heat exchangers are checked to detect blocked pipes. FLIR Systems thermal imaging cameras are also widely used for inspecting cracker installations. Many pipes and tubes in a cracker are insulated with heat-resistant refractory stone. Thermal imaging can easily see if the insulation is still intact.
Landsweeper automatically discovers and identifies
Steam traps are also subject to thermal inspections. Potential problems will clearly show up in the thermal image. Other examples are insulation breakdowns, hot spots in ovens, refractory insulation defects, damaged insulation, and breakdown of refractory on rotary cement kilns. During certain production processes, gases are generated which are burned off in flares. The flames generated can be invisible to the human eye. It's important to be sure that the flare is burning, otherwise harmful gases might enter the atmosphere. Thermal imaging can easily see if the flare is burning or not. Thermal imaging can also easily be used for tank level detection. Thanks to emissivity effects or to temperature differences, the thermal image clearly shows the level of the liquid. Thermal imaging can also easily be used to see if all barrels in a production process are properly filled. Thermal imaging is used in numerous industries. Other applications include finding hotspots in welding robots, inspection of aeronautical material, mold inspection, checking temperature distribution in asphalt pavements, inspection in paper mills. Whether you're interested in inspecting electrical installations, mechanical equipment, refractory, pipework or high-temperature equipment, flare and tank level detection, and many more, thermal imaging is the perfect tool for predictive maintenance inspections. FLIR Systems offers you the perfect solution for the most demanding predictive maintenance applications. From the extremely affordable FLIR i3 to the full feature.
در واقع میشه از همین کامراها برای ترموگرافی کانکروشر استفاده کرد و بسیار کاربردی و این کار واقعا با یه جواب زودهنگام هستش که میشه خیلی از مشکلات کانکروشر رو به سرعت حل کرد. خب اینو بریم ببینیم. این چون به زبان هندی صحبت میکنن
इक्विपमेंट का टेम्परेचर सेंस करना है, टेम्परेचर मेजरमेंट करना है, कितना हीट अप है.
یه خورده صحبت کردنشون اینم تقریبا شبیه به همونه. oil analysis start to finish. این 3 تا پارت داره فکر میکنم. حالا 2 تا پارتش اینجا معلومه. من توصیه‌ای که بهتون میکنم این که این مشابه شما دیدیم، این سه تا پارت خودتون ببینید، خیلی کار سختی نیست. اینو ببینیم با هم. خب
Hello, my name is Michael Stewart with Fluke Thermography. Today we're going to use thermal imaging to inspect a common electrical motor for issues that might be impacting energy usage. So we've done a little bit of prep work. We'll show you what we've done when we get over there, but the first thing you always need to have is proper equipment. Make sure you have a thermal imager, it's powered up, ready to go. Make sure you have proper personal protective equipment. Here we have an electrical motor coupled to a pump. The work that we've done in advance, obviously you can see that we've removed the shroud over the coupling and we've removed the cover over the junction box or the termination box. Need to have direct line of sight with thermal imaging in order to do a proper inspection. The first thing that I generally like to do is I'll take a look at the overall motor, the housing itself, and I'll be looking for unusual hotspots or localized hotspots that I wouldn't expect. In a normally operating motor, you would expect nice even heating and distribution across the entire housing of the motor. If you see anything that's off, that could be indicative of a problem. Likewise, if we look at this motor and it's running a lot hotter altogether over the entire motor housing, that's an issue as well. So let's take a look first and see what we find out. Looks quite even, I don't see any issues there. You know, obviously, if this motor were running hotter than usual, that could be an indication that perhaps the cooling fan's not working properly, it's not aspirating properly. I think everything's working okay here. Number one, because the temperature is good. Number two, the fan is operating. If I do find a localized hotspot, that could be indicative of a problem with one of the phases. Maybe some of the windings are burning out. Too much heat will destroy that insulation. Could also be an issue with transients on the line. Could be a problem with harmonics on the line causing unusual heating. Either one of these situations, the overall overheating or the localized overheating, can cause that motor to work a little bit harder than it needs to. It will draw more current in order to compensate for the problems that it has, and that will impact your bottom line and your energy usage. Next thing that I'll move on to is the electrical itself here in the termination box. I'll look for high resistance connections. So I'm not seeing anything here, but if I were to see a high resistance connection.
اینم بهتون بگم مثلا برای سیستم‌های الکتریکی، حالا این مدارها و سیم‌هایی که اینجا کشیده شده و جریان رو به خود موتور انتقال میده، ترموگرافی خیلی میتونه کمک کنه که ما بفهمیم که کدوم سیم بیشترین خطر رو داره در خودش توسعه میده، یا میشه گفتش که خطراتی که ممکنه که در اثر ولتاژ، حالا یا اختلاف ولتاژ یا اون شوک الکتریکی که به سیم وارد میشه، کدوم نقطه رو بیشتر در خودش تحریک کرده و جا داده. حالا تو صحبت‌های فیلم‌های قبل ما بحث هات اسپات داشتیم، منظورش همین بود که در واقع داشت صحبت میکرد. ببینید بقیه‌اش رو.
The shaft end of the motor, and I don't see any issues. If I were to see an issue here with this particular bearing,
در واقع بالا هم داره نشون میده 74 فارنهایت، درجه فارنهایت داره نشون میده به صورت آنلاین و ریل تایم. ببینیم بقیه‌اش رو.
Something's going on with that bearing. You need to do some extra work to try to figure out what's happening, because a misalignment, a bearing that's just wearing out, over lubrication, under lubrication, all of these things can also cause that motor and this motor pump assembly to operate inefficiently, draw more power, and not actually get the work done that you want it to do. So everything looks fine there, not seeing any issues. All right, you have to be a little bit careful when you're taking a look at couplings and shafts and things like that, because they tend to be a shinier metal, a lower emissivity material. So sometimes you can get reflections off of them that aren't really there and aren't indicative of the actual heat. In this case, I'm not seeing too much going on. I see a little bit of extra heating around, on the motor side of the coupling, but that could be an emissivity issue. I don't really know at this point. I'm not seeing anything significant. And because I'm not seeing any excessive heating on the bearing of the motor itself, tells me that more than likely the alignment's probably pretty good on here. So we're now going and going to take a look at the pump side and the pump. Don't see any issues here. I think this is operating really well. Any of these problems that I've discussed before is a great opportunity to say, okay, well, what do I do next? I've discovered something that may be draining energy, draining money out of my budget. How do we fix it? Well, you have to be able to diagnose it. So a lot of things, if you're finding a problem with a thermal imager and it looks like it's a bearing related or coupling related, you can then use a vibration tester. From an electrical standpoint, you find a high resistance connection or something looks like it might be overloaded, you can use a clamp meter. If you're finding problems that are localized hotspots, it might be a problem with internal windings, it's a good opportunity to use a power quality meter. It could be, as I said, transients, harmonics, anything like that. All of these tools work together in conjunction to help you better maintain your equipment and save energy over the long run. I hope this was helpful to you. As you can see, it's not rocket science. Anybody can do this. You can start.
خب و این آخریه هم ببینیم و توضیحاتی که مربوط به فصل 5 این پایان نامه بود هم به پایان میرسه. خب بریم جلو. همونطور که تایتلش میبینیم آنالیز روغن رو برای حالا اون قسمت موتور کشتی حالا گویا میخواد توصیف بکنه. بریم جلو.
Ayan guys, nalilisa natin yung mga lagay na samples natin. So make it sure lang na walang tubig para hindi palyado yung stick natin. So ngayon pupunta na tayo na natin kukunin is yung sa mga generators. So talagay yung dalawang bucket. Yung isa lagayan natin ng mga drain sample natin. So drain muna natin bago kunin natin yung samples. Okay, let's go!
خب چند دقیقه باید صبر کنیم تا این پست لود بشه تا بتونیم ببینیم. این در واقع موتور کشتی هست و حالا میخواد بحث آنالیز روغن رو برای موتور کشتی گویا انجام بده. ببینید یه چند ثانیه صبر کنیم چون گویا این فیلم قشنگیه، کمک میکنه که ما درک بیشتری از بحث آنالیز روغن داشته باشیم.
itong video na ito para magbigay ng basic na kaalaman ng mga aspiring cadets na hindi pa nakaka-onboard. I believe na alam niyo na yung theory para makapakita ko sa inyo. Ito yung element na gagamitin natin para sa pagkuha ng water content. So yan, reagent S. And then we have AC sheet base.
متاسفانه ما برای دیدن یک فیلم باید خیلی سختی بکشیم که یه اطلاعاتی رو از این فیلم بیرون بکشیم.
Doon sa shell. So, ito yung gagamitin natin, no? So, ito. Ilalagay mo dito sa loob, tapos i-mix mo. So, mamaya makikita nyo paano ito gawin. And then, sa pagkuha naman ng tigil, ito yung isa, pagkuha natin.
خب متاسفانه سرعت اینترنت خیلی پایینه، نمیشه دید. من دیدن این رو به خودتون محول میکنم تحت این عنوان. خودتون سرچ بکنید داخل یوتیوب به اسم ANSYS on board ship. این خودتون ببینید. تا اونجایی که امکانش بود و وقت به ما اجازه میداد در مورد این 4 تا هایلایت ها صحبت کردیم. امیدوارم که مثمر ثمر بوده باشه و خودتون دیگه من یه جورایی نقشه راه رو بهتون نشون دادم. میتونید با سرچ های متمادی توی یوتیوب به تکنولوژی های جدید، روش های مختلف و متنوع دست پیدا بکنید. با آرزوی موفقیت و پیروزی برای شما. شاد و سربلند باشید. خدا نگهدار.